Hey, thanks for checking out this video. Today I wanted to review another LinkedIn post that I thought had some really good information for software engineers. So this is not going to be my content, but I saw it on my feed and I thought basically all of the points really resonated with me, and I figured that I would share some of my perspective and we'll go through that together. So let's check it out. Alright, so this post is from Santiago Valdarrama. I hope I got his name right. Came up on my feed, and basically, like I said, all of these points really resonated with me. So let's go through these 9 lessons that this individual learned from spending 10 years with someone that he considers a brilliant software engineer. So the first one here says fast is better than good. Waiting too long, overthinking, and trying to get things right from the get go is a mistake. Most of the time, good enough is all you need. And this one really resonates with me because it reminds me of the 80-20 rule. And I think a lot of people have probably heard about that. And the idea is really that you don't need to go do everything 100%, get it all perfect, and, kind of spend so much effort and time on things because there are diminishing returns. And if you kind of read through this, the waiting too long, the overthinking, trying to get things right and get them perfect, right? That's like he's calling out, that's a mistake. You can kind of work through something. You can get something going, and a lot of the time that's kind of good enough to get to the next phase. Now, with more time, more experience, and the more senior you become as a software engineer, your ability to identify like what's important to be spending time on, that becomes a lot easier. So, right in the beginning, it's not like you're necessarily going to get this perfect because, well, and as it implies, there isn't really a perfect solution here, but just being able to move forward and make progress is really beneficial. Again, a lot of folks now as software engineers, there's a lot of focus on agile. I'm using air quotes here, agile software development versus something like waterfall, where you want to be able to iterate fast, you want feedback, and again, the more experience you have, being able to focus on what's important becomes easier. So that one really sticks out to me. I think that's great. This next one is interesting because I think as software engineers, we're always kind of looking at technical debt. So this says enough technical debt is a good thing, right? And a lot of us hear the exact opposite. So hating technical debt is nonsense. People just don't know how to take advantage of it. Technical debt means working on what truly matters and deferring anything that can wait. So if you take this in line with the first point as well, it's an interesting point because I think that, as people are working through code bases, think about if you've ever worked on a project where you joined and you weren't part of creating the code base from the beginning. There's always going to be these situations where you're kind of going through code, you're trying to learn it, and people will, you might be someone who's done this or you've heard other people do it where they're like, man, why is the code this way? Like, this is a bad way to write things, like knowing what we know now, like how did this ever exist? And that's the technical debt kind of adding up. So a lot of the time as software engineers, when we come across code that we just really don't want to like look at, we think it's designed poorly, we think there's optimizations that could be made, it could be more readable. The idea here is that you want to be able to prioritize it. You truly can't do everything. When we're thinking about software engineering with respect to actually, delivering value to customers, being part of a business, there just isn't time for everything. So having technical debt and having other priorities to focus on makes this really interesting. So this person's kind of saying like it makes you think about what truly matters and deferring the other stuff. So I think this becomes a really interesting conversation for software engineers that are trying to factor in business value, what to deliver on for customers, because if you're I'm just going to give you an example, right? If you're working in a code base where you've come across some technical debt and that code hasn't changed in, say, a couple of years, and for what it's worth, the planned features, the bug fixes, nothing's really in that area, like, is it worth spending time to go clean up that code? Like, probably not. Like, maybe you should be focused on trying to deliver the next bit of value to the customer. Now, in a situation where you're aware of the technical debt and it's aligned with where you're going to be iterating on in the code base, perhaps it's a really good opportunity to say, hey, let's pause for a second. Let's get this tech debt cleaned up. And that's going to make iterating and delivering more features more valuable and more easy. So I think this is a cool one because it's a bit of reframing for technical debt. So I like that. This third one, there aren't stupid questions. I love this, especially for folks that are joining new teams, new projects, new companies. So this says, he who asks a question is a fool for 5 minutes. He who does not ask a question remains a fool forever. And it says Chinese proverb. I actually I don't know if that's true or not. It kind of sounds like I don't know, like it could be, so I'm not one to claim that it is or is not, but the idea here I think is awesome. Um, I have this conversation, especially with more junior engineers or interns, a lot, but it's not restricted just to people that are early in career. This does come up a lot, and I think I'm not an expert in this, but I would think that as software engineers, we're generally people that are considered quite intelligent and we value intelligence. So I think for a lot of people, when you're asking questions, it can kind of come across like, or you might feel that if I need to ask, then that implies that I'm not intelligent, right? If I don't possess some knowledge about something, I am not intelligent. Therefore, people will look down on you, you'll look stupid, whatever it happens to be. And I think a lot of the time this is self inflicted, but I can speak from experience, especially, like I said, it comes up a lot more with junior software engineers. But I think the ones that really excel are the ones asking questions. They're the ones trying to unblock themselves. They're doing some problem solving on their own and then figuring out sort of that optimal time where they're like, okay, I've tried a couple of things. Now I need to ask questions about the best way forward, or they're asking clarifying questions early. So I think this one's great. I really wish that more people would take this to heart because I just think it's so valuable. And yeah, I go back to I suppose it's probably because as software engineers, um, people kind of feel that if they have to ask questions, maybe it comes across like they're not intelligent. Fourth one, communication outweighs technical skills. And I think there's a word missing here, but it says spend twice as much time learning, I think, how to tell stories than building technical skills. The ability to clearly communicate your ideas is a superpower. So, yeah, like, I mean, spend twice as much time learning. I'm not going to say that, like, whatever the ratio is. I think it's just for, making a point here. But honestly, being able to communicate is so important. If you think about how much remote work's going on as well, how much time as software engineers we spend on code reviews, in written communication, whether that's instant messaging, email, literally the code we write is written communication, right? So I think it's so important for us as software engineers to figure out how to actually communicate information, how to understand your audience, right? I've talked about this in different videos, but if you're talking with a software engineer on your team that's familiar with the code base you're working in, you can get into particular levels of detail that they're going to understand. If you're talking with a software engineer, they could be more senior than you and they're on a different team and they don't know your code base. You probably have to figure out a different way to communicate things, to navigate questions or challenges so that you can explain to them things that they're not going to know about your domain. And you can kind of keep exploring this with, like, if you consider different roles. So perhaps talking with your manager or talking with product or project managers, in those types of roles, I mean, it depends on the company, of course, but it's less likely that they're going to know the code base as well. So if you need to be talking about something like a bug fix for a customer, with the project manager, does it really make sense to be getting into lines of code and particular syntax? Like, probably not. In some cases, sure. Like, maybe they are technical in that field and they are familiar enough with it. So it's not a rule, but it's a guideline, right? So, having clear communication, working on that skill, I think is super important. I really liked this one is called out here. So, yes, technical skills are important, but in software engineering, in the real world, working on teams, we are collaborating. If you're just one person trying to do all of the work on a team or something, you'll never be as productive as the whole team working together, and that requires communication. Number 5, just because you can doesn't mean you should. Maximize the things you don't work on, learn to say no, prioritize, and delegate. You can only see what matters when you tune out the noise. Yeah, this is, I think, a really cool one to focus on. In some companies, some teams, how you're set up might mean that you have other roles like project managers, product managers, that kind of thing. Um, I think one of the most important parts about those roles is that a lot of the time, they focus on this type of thing for a lot of the stuff that you might, be considering having to look at. But it's not going to cover it all the time. So even if you have those roles kind of working with you on your team, they might be able to help on the coordination of stuff, or they might be able to kind of tell you from being a user proxy, like what's really important to focus on. But there's going to be stuff that, as a software engineer, you are still responsible for. And if you don't have those roles, you're going to have to try and figure that kind of stuff out as well when you're working on your team. So the important part here is that, kind of like I said earlier, you can't do everything. There's so many things, especially as a product is growing, a code base is growing, you start to have, paying customers, you have users, you have a live service, whatever it happens to be, like the more progress you make, the more stuff there is to do. Which, I mean, it sucks, but that's the way it is. So you can't just do everything. So I think it's really important. I think this piece just really talks about learning how to prioritize stuff is critical. And the priorities that you have on your project, the team has, the business needs, these are going to look different across different companies, different products, different projects. So I think just understanding that and learning, how to apply prioritization in your domain is going to be really important. Um, this is one of those things that I think is especially, again, going back to junior software engineers, or people that want to, they're trying to develop the skills to get into software engineering. A lot of the time, people are just focusing on code, right? They're gonna go try to do all the leet code problems. They're gonna watch all the YouTube videos on how to go make a website or a web server. But while these things are important, like prioritization is a really critical skill. We talked about communication. There's just these other things that you should be focusing on. Okay, let's head to number 6 here. Share like there's no tomorrow. People want to be around those who lift them, so share your knowledge indiscriminately. The quickest way to become a linchpin is making those around you successful. So, yeah, this is, I think it's really important. Again, like I think almost everything on this list is super important. So, when we talk about software engineers, and one of the things, in my opinion, for kind of leveling up as a software engineer, kind of working towards more senior roles as a software engineer, I think like this part here, making those around you successful. It's a leadership thing, right? As you become more senior, your expectations, I think in most places, your expectations around being a leader, and that doesn't mean a formal leader like in a management position, but being able to multiply those around you, level them up, making your whole team better by helping them, by sharing knowledge is critical. This is something I personally talk to individuals on my teams about as they're trying to gain experience. It's not just architecture and writing better code. Of course, these are things we focus on, but as they gain more experience, the words I have highlighted on the screen, make those around you successful. This becomes more and more of a priority. So I love this one. Okay, number 7, take full responsibility. Finding justifications is easy. Look inward instead. Learn your lesson and do better next time. Yeah, so I'm not going to necessarily speak to this exact wording here, but What I wanted to call out for this is something like a post-mortem process. I mean, you can use different phrases, but the idea is really like when things don't go the way you expect, it's good to reflect. And even when things do go the way you expect, it's good to reflect. So I think when I look at number 7 here, I think it's mostly focused on, when things don't go right, like what do you do with that information? So, sure, if you're reviewing, say, a bug happens, like a bug's detected by customers, they're reporting it. Now the team's got to go through getting a fix out, like communicating with customers about the fix, all that kind of stuff. And of course, this looks different everywhere, but just an example. You might go through a process of reflecting on this, and it's, okay, you're on a team of 5 people, and turns out Bill on your team, the intern Bill, committed code, introduced the bug. So, okay, it was Bill's fault. Was it though? Is Bill the only person that had to get that code all the way out to production to customers? Who reviewed that code? Were you on that review? Was someone else on the team on that review? Who wrote the tests for that? What's the testing infrastructure look like? Right? You can start to go through this process, and really what it comes down to is like, it's not ever going to be one person's fault. You are working as a team. So I think in this particular case, it's really not about like, trying to identify like who done it. It's really about like learning from the situation how to apply those lessons. Doesn't matter if it was you, someone else that ultimately wrote the line of code, or press the press the submit button, whatever it happens to be. I think it's really critical that holistically you look at the different things that happened and just try to understand and do better next time. So I like this one a lot. If you don't have a process where you're working that kind of does this reflection process, I think it's absolutely worth bringing up. Again, you can apply it for positive or negative scenarios. And regardless, I think that the like you take a no blame approach and just try to learn and get better. Um, it's honestly like a fascinating thing to go from not having that on a team to having it and just watching the whole team get better and grow. If you do have something like this and there is a concept of blame, I think it can really backfire. So I think this part here that says look inward instead is critical for making this work effectively, right? So again, no blame process, review positive and negative things. Retrospective, I think it's great. Number 8 says the best code is the one nobody wrote. I think this is interesting. It says code is a liability. Learn to solve problems by writing as little code as possible. No code solutions are an underappreciated superpower. So I wanted to talk about this one from the perspective of prototyping and rapidly iterating on things. I've spent a lot of my career, especially early in my career, working on teams that did rapid prototyping, and I think one of the most important parts is really just getting to answers fast. I think that's the way that I would phrase it. Get to answers fast. And what does that mean, right? So if you're thinking about prototyping something and why you do that, the idea is that someone's considering that there may be a solution for a problem and there's an idea for how to solve that problem. But I think as soon as you have to go start writing code, code may be a solution to the problem, right? You can go code something up and whatever it might run and you have a UI, whatever, people are trying it out, but is that the quickest way to get your answers? And I think that's a really important thing to consider when you're prototyping because I'm just going to give you an example. If you're prototyping something to figure out if users would be interested in it, do you need to go through the steps of creating a new application with a UI, deploying it, having users get onto a web page? I mean, you might in your particular situation. In other situations, maybe you have a product team that's able to interface with customers directly. Maybe you already have, an existing application where you can try to drop a small page in. I mean, that's going to include some code, but can you minimize the amount of code? Can you get that question answered with like what if you made a PowerPoint and presented it to customers or users, right? Potential users. Um, Being able to do something like that just has like such little effort compared to, writing code, getting your tests in place and getting the build going and then pushing it to production. Like those are great things, but they might not be the best or quickest tool to go get your answer. So I'm not sure if that's what this individual meant when he was talking about number 8 here, but when I think about the way this is written for number 8, I always kind of reflect back to that rapid prototyping thing. And, as software engineers, we love to write code. We love writing code to solve problems. We love writing code to answer questions. But I think it's a really good opportunity to press pause and kind of go back and think about like, do we really need code to get this answered? Okay, number 9 is probably one of my most favorite on this. It says, if you don't test it, it doesn't work. Any code that can break will eventually break. If you don't have automated tests, you are doing it wrong. Now, that's a really strong statement, um, but I like the phrasing in this because it is polarizing. Um, I'm a I'm a really firm believer in having automated test coverage on your code. Now, I did talk about rapid prototyping right before this. That's an example where like testing it to me doesn't really make sense because hopefully you didn't even have to write code in your prototype, right? You're just trying to get questions answered. Your prototype, if you did write code, that's probably going to get thrown away, right? So tests in that case, I don't think help as much. So it's not a rule, but I like this a lot because I think um, a lot of the time as software engineers, when we're coding up solutions, we might we'll go run it on our computer. We'll go flight out a change for a service. And we're checking machines, or we're doing something manual and going, okay, like that fixed the problem. If it was a bug fix, or you have a feature and you're testing it out by manually running things, you'll great. Like it worked. And that's good. Like you should you should be testing your things to prove they work in some capacity, right? Not just blindly pushing stuff to production and crossing your fingers. But the part that's important here is it says any code that can break will eventually break. And the automated test part, that's where this comes in. So just to give you an example, right? If you and I are working on a team and you go push up a code change, and let's say it's something for a live service and it has to go through some A/B testing or some flighting. So it's rolling out, the data's coming in, it's all working, and you're going, yep, awesome. My change is perfect, it's working. We got green lights everywhere. Great. Cool. Now I come in and I go, oh, I'm going to deliver this other feature. And I go do the same steps as you, right? So I'm gonna go commit something. I'm gonna go flight it out, and I'm getting green lights on all my stuff. So great, I did a perfect job too. But what happens if what I was delivering and flighting out actually ended up breaking what you wrote? You didn't have automated tests in place. Now we don't know if it broke. Now we have to wait for a customer to tell us, hey, this doesn't work. Or customers don't tell us and someone else comes across it. Someone internally goes, oh crap, this is broken. Either way, it sucks, right? It's going to mean that you might have to revert stuff, or you're going to have to, depending on your scenario, have to try and get a patch out, whatever it happens to be. But the idea here is that if you are getting stuff landed into production, I do not think it's sufficient to just manually test something, the one time, even if you're flighting it out slowly, like that's great. But if there's no automated tests that help with regressions, I think personally that is a recipe for disaster. Um, to say you are doing it wrong, like I said, I think that's probably the polarizing part. So, um, my opinion is, yeah, like that is not the right thing to do. Now, as a rule, I don't really like saying I don't like having rules because I think there's always exceptions to every rule, but um, I honestly do think that this is a practice that you want to have. You do want to have automated regression tests. Um, I just think it's super important. And if you're in a position where you are delivering code and saying, well, there is no way to test this automatically, it has to be flighted out. No, I think that's incorrect. I think the correct thing to say is you might have to flight it to validate it, but once it's been validated, can you look at your automation and figure out how to prove that that behavior still happens? Now, your test infrastructure may not be able to support it currently, and that's okay because that's an area that could be invested into. But to say that you can't write tests on something to validate it, I think that that's just missing the point. You can validate things manually, but you need to look at ways to have automated regression tests separately. All right, so that was a list of 9 things from Santiago Valdarrama. Again, I hope I got his name right. I really like that list. I think that personally, everything on that list is something important that's come up when I'm talking with junior software engineers all the way through senior software engineers. I think a lot of those lessons are personally things that come up that aren't super technical, right? They're not like, oh, like using this programming language and following this design pattern, like that's the way to success. Like, yes, there are technical things you want to focus on as software engineers, but I think that was a really good list of 9 things that are basically going to help you just level up as a software engineer in general. So I'll put a link to this post in the description. I want you to go check it out, leave a comment. I think this is great. So thanks so much for watching, and we'll see you next time.